Here's a change in pace. Notice how with this improper integral, it's improper because I have an unbounded bound of integration in two different situations or two different places. Now, legally to handle this, what I can do is rewrite this as a sum of two integrals. Because a function in the integrand's position is continuous everywhere, I can choose any value of x to separate that one integral into a sum of two other integrals. Now, both these integrals are improper. I'm still going to have to evaluate them by rewriting them as a limit of a proper integral. But I think because there's so much symmetry involved with the graph of this equation, y equals that beast, clearly it's just a bell-shaped curve, isn't it? So I do think I can exploit symmetry. And if maybe on one side I have an improper integral that converges, I can just double the result to get the entire area underneath the curve from that extreme to that extreme. To exploit the symmetry, I do think I should be a little more intelligent in how I split up that one improper integral into sum of two others. I will split up as such. So again, if one of these converges, I will simply double the result to get the evaluation of this integral, or shall I say, get the area that's finite of the unbounded region. So, taking a peek at just one of them. How about the latter? So in considering the evaluation of this improper integral, I must first rewrite it as a limit of a proper integral. And our deep REM sleep piece take to anti-differentiate that function in the integrand's position. I will evaluate that antiderivative at the upper bound of integration, at the lower bound of integration, and look at the difference. Of course, that second term merely goes 0. I do think as t increases that bound, the first term is merely going to go to pi halves. That being the case, I do think this improper integral converges. And in particular, it converges to that value. So I guess in the end, that must mean, due to symmetry, that I have that value pi halves duplicated twice. And here is a sum.